Hello, and welcome to Today in Physics. I am Sir Nigel Crothers Edmund the 23rd, knighted by Queen Elizabeth II in 1969. I hold an office as Professor of Physics at Oxford, and have the highest degree that you can possibly get in the field of science. Besides that, I'm an avid member of the book club there. I also have a AAA card, and go to Sears quite frequently. But now, on to the topic at hand. Forces. Everything in the world is controlled by forces. Gravity, it's all held together by forces, such as this. What is a force? Now don't answer that. It's a rhetorical question. It means you don't have to answer it. And even if you did, I wouldn't be able to hear you because this is a tape recorded many days before you even are watching it. But back to the question at hand. Forces. These things that hold our universe together and control everything in our daily life. But do we really understand them? These are the things that we are going to be looking at more closely today. Let's take a look at some examples of forces. This is a force. This too is a force. This is a force. As much as I would like to deny it, that too is a force. That also is a force. That is a force. That is a force, and that is a force. And this too is a force. Ow!
Excuse me, sir, are you a real physicist?
Yes I am.
Well, lucky me. We're trying to find out what exactly is a force.
Well, let me check my physics book. Physics book.
Physics book? I'm sorry, I don't know that word.
Yeah, you don't use these much in high school. Anyways, a force. The concept of force. If you pull on a string, as in figure 4a,
Actually, figure 4A is right here.
oh yeah, figure 4a, if you pull on a string, as in figure 4a, the spring would stretch. If a child pulls hard enough to pull a wagon, that is a force. When a football is kicked, that is a force. When you bring a magnet close to another magnet and they slide apart, that is also a force. So you see, it's quite elementary. Those are forces.
Seems pretty simple.
Yes, it is.
Where could you get one of these book physics?
Oh, you can have mine.
Physics books.
I don't use it.
Thank you, mister.
Uh-huh.
Come on, come on. Come on, come on. Because you're probably not all advanced
Yeah, that's a physicist.
people who know how stuff moves, we're going to simplify Newton's 3 laws so that you can understand them. The first 3 laws of Newton, so that you can understand them. First of all, Newton's first law. An object at rest will remain at rest. Or in other terms, the velocity of an object will not change unless acted upon by an outside force. Take this Gatorade bottle conveniently placed here by our prop team, for example. The force of gravity pulling down is equal to the contact force between the table and the bottle pushing up. Because these forces are equal and in opposite directions, they cancel out, and there are no other forces acting upon the Gatorade bottle, so it doesn't move anywhere. Force
forces! Yeah!
Everything, atoms, molecules, they're all together by forces. Oh, wonderful!
Can't touch this.
Pretty nifty, huh? Here is another example of an object at
Can't
rest.
touch this. Can't touch this.
But when acted upon by an outside force, Eureka! He moves!
My music hits me so hard, makes me say, oh my Lord, thank you for blessing me. What am I to rhyme and do?
Wait. This just in. Newton's second law. The net force on an object is equal to the acceleration times the mass of that same object. In other terms, what this means is the total force on this Gatorade bottle. All these forces working on it. We get that a lot in the studio. All the forces working on this Gatorade bottle are equal to the mass of this Gatorade bottle times the change in speed and direction over time. Isn't that great?
Liquid physics. It's in me. Is it in you?
This brings us to Newton's third law, which states that for every force there is an equal and opposite force. Now, what this means is that you have an object, and it hits another object so that object A is exerting a force on object B, like so. Object B is exerting the same force, but in an opposite direction. So when these two hit, they're really exerting the same amount of force against each other. Let's look at another example. Book. When I take this physics book and smash it against my head, the book will exert a force upon my head, but my head will exert an equal yet opposite force against the book. Pardon me, I value these glasses very much. Now, let's see how well this will work. Oh God, that hurt! And another thing, an object cannot exert a force on itself.
Hey, crap, it's not worth it.
You all right there, Jordan?
Yeah, I'm fine. I'm good. I'm okay.
You know we got another law to go, right?
There's another law?
I'm just kidding.
Things that make you go,
Grand unification theory. Weak nuclear force. Strong nuclear force. Electromagnetic force. Gravity. Static force. Friction. Normal force.
things that make
Force
you
of
go,
tension. Force of a push.
Robbie Rob, break it down.
Gravitational field constant.
Boson.
Graviton.
Electron.
Gluon.
Proton.
Neutron.
Positron.
Color.
Color.
That make you go. Things that make you go.
This just in! Physics is happening right now, all around us! Quick, let's see if we can get a look! Jeez, that really hurt.
Things that make you go.
And now, the long-awaited Happy Physicist Dance.
Get your motor running.